Welcome to True Projects. In this video, we are going to explain about the project, which is Artificial Intelligence Applications in K-12 Education, a Systematic Literature Review. Introduction. Education plays a crucial role in societal development, continuously evolving in terms of teaching methods, content, concepts, and models. Recently, there has been a growing recognition of the potential of artificial intelligence in addressing various educational challenges. This project is centered on the integration of AI in K-12 education, encompassing both primary and secondary school levels. The main objective of the project is to study and analyze the applications of AI in education, aiming to gain valuable insights that can contribute to the development of improved AI-based educational systems. Ultimately, the project seeks to enhance the quality of education for students by leveraging AI's capabilities to create more effective and personalized learning experiences. The primary objective is to conduct a thorough evaluation of the current status of AI integration with K-12 education. Employing a range of AI algorithms including logistic regression, random forest, decision trees, k-nearest neighbor, support vector machine, naive bayes, XGBoost, and more. The choice of algorithm depends on the specific educational task at hand. Making the use of datasets containing crucial information related to various aspects of education such as student performance, behavior, teacher feedback, and other pertinent educational data. Applying these AI algorithms to analyze and predict diverse facts of education including student performance, student behavior, and teacher feedback. These algorithms will use the dataset as input, allowing for the identification of patterns and insights that can be used to inform and enhance the educational practices. Requirements of the project are hardware and software. Coming to hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above are needed to implement the project. In software, we need Anaconda 3 and Visual Studio Community version. The algorithms used in this project are: the first one is logistic regression. It is a statistical method used for binary or multi-class classification. It models the probability of a binary outcome. Random forest. It is an ensemble learning method that combines multiple decision trees to make predictions. It is used for both classification and regression tasks. It is employed to handle complex relationships in the data, often providing better prediction accuracy than individual trees. Decision tree. It is a tree-like model that breaks down decision-making into a series of choices and consequences used for visualizing and analyzing decision factors within datasets, including identifying important features. MNB, which is multinomial naive bayes. It is a probabilistic classification algorithm based on Bayes' theorem. It is suitable for text classification. It is applied for text-based analysis such as categorizing teacher feedback or classifying textual data. SVM. It is support vector machine. It is a powerful supervised learning algorithm that used for classification and regression tasks. It aims to find optimal decision boundaries. It is used to classify and analyze data based on distinct patterns suitable for various domains. CAT boosting, which is categorical boosting. It is a gradient boosting algorithm that is designed for categorical feature support. It is used for classification and regression tasks. This is suitable for the datasets with categorical features and help in improving predictive accuracy. Voting classifier. It is an ensemble learning method that combines the predictions of multiple machine learning models. It is used to increase prediction accuracy by aggregating the outputs of multiple algorithms such as logistic regression, random forest, and support vector classifier. RNN, which is recurrent neural network. Recurrent neural network is a type of neural network that is designed for sequential data, allowing them for informating the persistent through time steps. It is applied for tasks involving sequences like analyzing student behavior over time or processing sequential data. LSTM. It is long short-term memory. It is a type of RNN with specialized architecture that helps to overcome the vanishing gradient problem. It is used when modeling long-term dependencies in the sequential data, such as predicting student performance trends. CNN. It is convolutional neural network. It is a deep learning model that is designed for image and spatial data featuring convolutional layers. It is applied when working with the image data such as analyzing images related to student behavior or performance. Ensemble model with CNN with LSTM. An ensemble of convolutional neural network and long short-term memory models combines the strength of both architectures. It is used to improve predictions by leveraging CNN for spatial data and LSTM for sequential data in combined manner. DNN, which is Deep Neural Network. It is a type of neural network with multiple hidden layers designed for complex patterns recognition tasks. It is applied for various tasks such as pre-processing user inputs and making predictions in Flask framework. KNN, which is K nearest neighbor. It is a classification algorithm that assigns a data point to the majority class of its K nearest neighbors in the feature space. It is used for the tasks like predicting student performance based on similarity to other students with known performance. XGBoost, which is extreme gradient boosting. It is an optimized gradient boosting algorithm known for its speed and performance. It is used for both classification and regression tasks. It is employed to enhance prediction accuracy in tasks like student performance prediction through boosting. Gradient boosting. It is an ensemble learning method that builds multiple decision trees sequentially, each correcting the errors of its precedor. It is utilized to improve the prediction performance of various tasks, including student performance and behavior analysis. Bagging classifier. It is an ensemble learning method that creates multiple subsets of the dataset and trains separate models on each subset. It helps to reduce overfitting and improve the robustness of predictions, often used in combination with decision trees. Naive Bayes. It is a probabilistic classification algorithm based on Bayes' theorem. It is used for text classification and other tasks. It is applied for text-based analysis such as categorizing textual data or text-based sentiment analysis. OSELM, which is Online Sequential Extreme Learning Machine. It is online machine learning algorithm designed for sequential data. It rapidly trains a single hidden layer feed-forwarded neural network. It is applied to analyze and predict sequential data, making it suitable for student behavior analysis. Boosting. It is an ensemble learning method that combines multiple learners to create a strong learner, used to improve prediction accuracy by combining the outputs of multiple models, often decision trees. Stacking classifier with AdaBoost, XGBoost with RLR. Stacking is an ensemble learning technique where multiple models are trained and their predictions are combined using another model, employed to improve prediction accuracy and robustness by combining the strength of AdaBoost, XGBoost and logistic regression. For implementing this project, we have designed few modules in the flow of work. The first one is importing the packages. Necessary libraries and modules are imported for teacher feedback module. NumPy is used for numerical operations and Pandas is imported for data manipulation, TensorFlow for deep learning, Matplotlib for visualizations and Seaborn also for visualizations and scikit-learn for machine learning models. Exploring the dataset using teacher feedback data. The data related to teacher feedback is explored and examined. Data processing. Tokenization of feedback. The textual feedback provided by the teachers is tokenized, breaking it down into meaningful units. Count vectorization. The tokenized feedback is converted into numerical data using count vectorization, which represent words as numeric features. Visualization using Seaborn and Matplotlib. Data visualizations are created to better understanding the feedback of the data. Feature selection using Pandas iLog. Relevant features or columns from the dataset are selected for the analysis. Splitting the data into train and test. The dataset is divided into two subsets, one for training the machine learning model and other for testing its performance. Building the model. The various machine learning models are built using the machine learning algorithms, which are logistic regression, random forest, decision tree, MNB, which is multinomial naive Bayes, SVM, CAD boosting, voting classifier for logistic regression, random forest and support vector classifier, RNN, LSTM, CNN, ensemble CNN with LSTM, DNN and training the model. Various machine learning models are such as logistic regression, random forest, decision trees and other are constructed to predict, analyze teacher feedback, and the selected machine learning model is trained using the training dataset. Coming to the next module, which is importing the packages. Similar to the teacher feedback module, necessary packages are imported for this module for the student performance dataset. Exploring the dataset. Data related to student performance is explored and analyzed. Data processing. Using Pandas data frame, the data is organized and pre-processed. Keras is utilized for data validation and processing. Visualization using Seaborn and Matplotlib. Visualizations are created to gain insights into the student performance dataset. Feature selection using Pandas iLog. Relevant features from the dataset are selected for the analysis. Splitting the dataset into train and test. The dataset is divided into training and testing subsets. Building the model. For student performance dataset, we have built multiple machine learning and deep learning models, and they are random forest, decision tree, KNN, SVM, logistic regression, XGBoost, voting classifier, gradient boosting, bagging classifier, DNN. Coming to training the model, the selected machine learning model is trained using the training dataset. Importing the packages. Necessary packages are imported for the student behavior dataset. Exploring the dataset. Data related to student behavior is explored and examined. Data processing. Using Pandas data frame, we have organized and processed the data. Using Keras validating, Keras is used for data validation and processing. Visualization using Seaborn and Matplotlib. Visualizations are created to better understanding of the student behavior data. Feature selection using Pandas iLog. Relevant features from the dataset are selected for the analysis. Splitting the data into train and test. The dataset is divided into training and testing subsets. Building the model. The various machine learning models are constructed to analyze and predict student behavior. The first one is logistic regression, SVM, naive Bayes, random forest, OS ELM, XGBoost, bagging, boosting, gradient boosting, voting classifier, stacking classifier, FFNN. Coming to the training the model, the selected machine learning model is trained using the dataset for student behavior data. Flask framework with SQLite for sign up and sign in. Flask, a web framework, is implemented along with the SQLite database for user registration and sign-in functionalities. Importing the packages. Necessary packages for the web development using Flask are imported. User gives input. User provides input in the form of feature values for different aspects such as student performance, student behavior, and the teacher feedback. The given input is pre-processed for prediction based on the input. The given input is pre-processed to make it suitable for prediction based on input features. The trained model is used for the prediction. Trained machine learning models are used to predict outcomes or provide insights based on the user input. Final outcome is displayed through front-end. The final outcomes or the insights are displayed to the user through the front-end of the web application. Comparison graph for the student behavior dataset. Here on the x-axis, we have the accuracy scores, and on the y-axis, we have the algorithm names, and this graph represents the accuracy comparison graph for all the algorithms. And this is the accuracy comparison graph for student performance dataset. Here also on x-axis we have the accuracy scores, and on the y-axis we have the algorithm names. This is the comparison graph for teacher feedback data, where x-axis represents algorithm names and the y-axis represents the accuracy scores. Among all the comparison graphs, the best performed algorithm will be selected for the prediction purpose in the web interface. For execution of the project, first we need to open the code folder of the project, where it contains source code files. This is the static folder. This folder consists of the files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python. that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And this is the IPYNB file, and we have other IPYNB file which are performance IPYNB file. And these is the Jupyter Notebook files which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. And this is the sign up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So we will copy this code. Now we will open the Anaconda prompt. Using the cd command, we will paste the copied path. This command is used to change the current directory to the code folder's path. Now we need to click on enter. So the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile the app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost, and the port number unless configured differently. So this is the localhost and this 5000 is the port number. Now we need to copy this local link provided by the Flask framework and paste it in any browser. I prefer Google Chrome, so I will paste it in that. So here we will paste the link and then click on enter. This is the homepage of the project, which is displayed in the web browser, and this front end is built by using the Flask framework. Now we need to click on sign up. So for registration process, we need to fill all these registration details if we are registering newly. I have already registered, so I'll directly click on sign in. Here I need to provide my credentials, which are my username and the password. By clicking on register, we will be logged into the home page. So this has redirected to the home page of the project, where we need to provide the message in the input box and then click on predict. And then we will have the negative sentiment or the positive sentiment for the feedback provided by the teacher. Now we will enter the message here. So in the text box, I have given the feedback of the teacher for the student. Now we will click on predict. Based on the feedback, it is predicted that it is a positive content, which means the feedback is positive. Now we will give the other feedback. I entered the message here. Now we will click on predict. Based on the input provided, we got the feedback as negative content, which means the student performance is negative. Now we will give another text and then see what will be predicted. I entered the other message. Now we will click on predict. Based on the given message, it is predicted that it is the positive content, which means it is the positive feedback. Now we will give one more message. I gave the message here. Now we will click on predict. Based on the given feedback, it is predicted that it is the negative content. In this way, we can give any input message of the student. For that, we will get whether the student performance is better, good, bad, negative, or positive. Now we will sign out of this web page. Conclusion of the project is: the project has successfully provided a comprehensive overview of the current state of AI generation in the K-12 education, shedding the light on both its strengths and areas of improvement. Through a systematic literature review, various AI applications within K-12 education were systematically categorized into distinct areas including student performance, teachers' feedback, behavior tasks, and others. This categorization helps to clarify the diverse applications of AI in educational settings. Among the identified AI approaches, machine learning and intelligent tutoring systems emerged as the most frequently utilized methods in the context of K-12 education. These findings underscore the dominant role of these technologies in transfer education. The project's findings have yielded valuable insights into the potential benefits of AI in K-12 education. These insights can serve as a guide for educators and policymakers, informing their decisions on the implementation of AI-based educational systems. The ultimate goal is to leverage AI to enhance educational outcomes for students, ensuring a more personalized and effective learning experience.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.